Welcome to Science and Engineering World, where we do mathematics, more mathematics, much more mathematics. In a previous video, which I will put the link up here and in the comment section below, I illustrated the steps in completing the square method. I explained that this method can be used to solve almost all quadratic equations. In this presentation, we shall go through the steps to solve a typical quadratic equation problem. My name is Olutola Fakehinde. Quadratic equation solution. This is a typical quadratic equation problem which says 2x squared plus 11x minus 40 equals to 0. However, before we go to solve this problem, I encourage everyone watching this video to give us a thumb up. I also encourage you to send this content to so many of your mates and friends. And if you have not subscribed to this channel, please subscribe. Subscribing to this channel will support us in so many ways. We appreciate you for doing this. Now to the problem. Let us look at the solution to this quadratic equation, which says 2x squared plus 11x minus 40 equals to 0. And we're going to use, like I've said earlier, completing the square method to solve this problem. The first step in the completing the square method is to use the coefficient of x squared to divide through the equation. And what is the coefficient of x squared here? That is, if you remove x squared, what is left is the coefficient, and here it is 2. So we are going to use this 2 to divide through the equation. That is 2 dividing both left and right hand side. And so we have here 2, we cancel 2, and then 0 over 2 will also give us 0. And our expression will now become x squared plus 11 over 2x minus 40 over 2 equals to 0. So we call this equation 1. Step 2 is to separate the variables from the constants. And what do we mean by variables here? Variables are figures that has x attached to them. In this case, we have x squared here is carrying 1, so we have 1x squared. So that's a variable, and this is also a variable. The one that we refer to as constant has no x, so minus 40 over 2 has no x, so it's referred to as a constant. In order to remove it from the left hand side, because it carries a negative, this time we will have to add it to the left hand side and at the same time add it to the right hand side. And so we have this expression. And from here we see that minus 40 over 2 plus 40 over 2 will disappear, become 0. And then we have 40 over 2 here will give us 20. And so our expression becomes x squared plus 11 over 2x equals to 20. And we'll take this as equation 2. Step 3 says that we should have the coefficient of x, square it, and add it to the two sides of the equation. So we have 3 operations here: half, square, and add. So we're going to first of all take the half of the coefficient of x, then square it and add it to the two sides of the equation. And what is the coefficient of x? Like we have done in x squared, if you take x away from here, so what we have left is going to be the coefficient of x. So coefficient of x is 11 over 2. Now, the first operation says half of it. So what is the half of 11 over 2? That is 11 over 2 times half. And that gives us 1 times 11 is 11, 2 times 2 is 4. So that gives us 11 over 4. The second operation says we should square 11 over 4. So the square of 11 over 4 will now give us 11 over 4 bracket square. And so we add this to this expression, and then we now have that, which gives us equation 3. This is completing the square. In step 4, we want to factorize the left-hand side, and also later on we do the same for the right-hand side. The left-hand side is that, and we want to factorize this. In factorizing this, we take the coefficient of x squared, the coefficient of x squared, which is going to be 1 here, and then the constant. So we look for the products of the coefficient of x squared and the constant. And the constant is this here. Alright, so that is coefficient of x, which is 1. Coefficient of x is 1 times the constant. That's 1 times 11 over 4 bracket square. We want to find the factors of this. If we have a squared, the factors of a squared will be a and a. Because a times a will give us a squared. So same thing here, 11 over 4 squared, we have its factors as 11 over 4 and 11 over 4. What are we doing? We're trying to find these factors in such a way that if we add the factors together or subtract one from the other, we're going to get the coefficient of x here. And so 11 over 4 and 11 over 4, adding them together should give us the 11 over 2. So we now use these factors to rewrite the expression in this form. So we now have 11 over 4x plus 11 over 4x. If you add these two together, you're going to get this. Now, the next step we want to look at is to combine the first two terms and the second two terms together. Now, in the first two terms, what is common to both of them? From here, we see that x is common, so we take the x out. And once we take the x out, we see that x will go in x squared to give us x. X will go in 11 over 4x to give us 11 over 4. We have the plus in between, the plus will come, and then we look at what is common to the other two terms here. We will see that it's going to be 11 over 4. So if we take 11 over 4 out, 11 over 4 in 11 over 4x will give us x, and 11 over 4 in 11 over 4 square will give us 11 over 4. The two brackets here are similar. So we will now factorize the two brackets to give us, bringing one of them out, we can now combine this and this together to give us that, and then one of the brackets will also be written. And so we have here x plus 11 over 4 to bracket square. In step 5, we want to look at the right hand side. So we open the bracket on the right hand side and then simplify. So opening the bracket on the left hand side, we now have 11 over 4 times 11 over 4, which will give us 11 squared over 4 squared. So we have the first step, that is simplifying the right hand side, to now give us 11 squared over 4 squared plus 20. We have opened the bracket to give us that, so we need to simplify this. What is the LCM for these two? We have 4 squared to give us 16, so we take the LCM of this to be 16. 16 and 16 give us 1. 1 times 11 squared will give us 11 squared. And then we have 1 here. And so 1 in 16 will be 16. 16 times 20 will give us that. So we now have our right hand side to give us 11 squared plus 16 times 20 is 320 over 16. In step 4 and step 5, we have first simplify the left hand side and the right hand side. So in step 6, we bring the two of them together by combining left hand side and the right hand side. The left hand side is that and the right hand side is this. Putting the two of them together gives expression 4. In step 7, we want to find x. But this x is inside a bracket that has power of 2. So in order to be able to take this x out of this bracket, then we need to find the square root of the left hand side. And once we find the square root of the left hand side, we are going to find the square root of the right hand side as well. And so we have here square root of the left hand side and the square root of the right hand side. Looking at the square root on the left hand side, we see we can simplify by turning the square root to power of half, because square root is power of half, and so we're going to have this. So this square root sign here is now translated to power of half. And using indices, we have a to power n bracket m to be equal to a to power n m. Opening the square bracket, we're going to have 2 multiplied by half, and 2 divided by 2 will give us 1, and so this becomes x plus 11 over 4. Meanwhile, we are dealing with quadratic equation. Where we started, we have 2x squared. So in that case, we're going to have 2 roots of this expression. And so we need to add in that plus or minus. This plus or minus will give us the 2 roots of this equation. In step 8, we are still looking for x. Simplifying the right hand side, we write the numerator and the denominator separately by having the square root of the numerator and the square root of the denominator. Well, we know that the square root of the denominator, which is square root of 16, will be equal to 4. So we put this in the expression, and that translates our equation to this. Step 9, we are still looking for x, and for us to find x from here, we need to separate the constants from the left hand side. And to separate the constant from the left hand side, we must remove that constant on the left hand side. So we subtract the constant 11 over 4, that's plus 11 over 4 from the left hand side, and we must also do the same to the right hand side. So we now have that expression whereby 11 over 4 on the left hand side, we cancel 11 over 4 here, and we now have expression x equals to minus 11 over 4 plus or minus square root of 121 plus 320 over 4. Step 10, we want to simplify the right hand side. The two terms in the right hand side are the same denominator. Minus p over y plus or minus q over y, because they have the same denominator, is going to be y. And that will give us minus p plus or minus q. So we can write our expression in that. However, 121 plus 320 equals to 441. So that will give us the expression there. And square root of 441 is 21. This 21 times 21 should give us 441. So we have that expression. That gives us the value of x. And like we said before, because it's a quadratic equation with x to the power 2, we now have two roots, in minus 11 plus or minus 21 over 4. So the first value of x, which we call x1, will give us minus 11 plus 21, or the second value will give us x2, which should be minus 11 minus 21. In the first value, minus 11 plus 21 will give us 10 over 4, and the second value, minus 11 minus 21, will give us minus 32 over 4. Going further, we can write x1 to be 5 over 2, or x2 to be minus 8. Step 12, we want to verify if the roots we have obtained will satisfy the equation 2x squared plus 11x minus 40 equals to 0. And the roots we have are x equals to 5 over 2, that's the first one, and x equals to minus 8. So let's see them one after the other. When x is 5 over 2, then we are going to substitute 5 over 2 into this expression when we see x. In that case, we are saying that 2 times 5 over 2 squared plus 11 times 5 over 2 minus 40 equals to 0. 5 over 2 times 5 over 2 will give us 25 over 4 times 2. Then 11 times 5 over 2 minus 40 equals to 0. 2, we cancel 2 here to give us 2. So we are going to have 25 over 2. 11 times 5 is 55 over 2 minus 40 equals to 0. because we have fraction here and fraction here. So the best way to go about this is to multiply the whole expression by 2. So multiplying the expression by 2, we are going to have 25 plus 55 minus 80 equals to 0. 25 plus 55 is 80. So we're going to have 80 minus 80 equals to 0. And so the first root that says x equals to 5/2 satisfies the equation. Substitute x equals to minus 8 into that expression. We give us 2 times minus 8 squared plus 11 times minus 8 minus 40 equals to 0. Minus 8 times minus 8 will give us plus 64. That is minus 8 times minus 8 will give us 64, because minus times minus is plus. Then 11 times minus 8 will give us plus times minus will give us minus 88. So we have our expression to now be 2 times 64 will give us 128. And 11 times minus 8 is minus 88. So we have 128 minus 88 minus 40. We can go this either way by adding the minus and minus together according to BODMAS. And so we have here 128 minus 128, because minus 88 minus 40 will give us minus 128. And again, this gives us 0. So the expression 2, the root 2, satisfies the equation. So our quadratic equation 2x squared plus 11x minus 40 equals to 0 has 2 roots, which are x equals to 5/2, that's the first one, and x equals to minus 8. And we have seen that these 2 roots are in agreement with the equation. If you find this video very useful, give us a thumb up, and at the same time share to others. Make comments so that we know how far we've gone with this, and if you need any further clarification, let us know in the comment section below. At the same time, keep subscribing. Subscribe if you have not done so. We need to make this solution to go to the other part of the world, so this will help us. And I always say this: you can find a joy in doing mathematics, and so keep having fun. And lastly, keep studying.